Hey everyone, welcome to Tech Tuesday. I'll be right back with special guest Alexander Britkin from NFWare. See you in just a moment. Hey there, folks. Again, welcome to Tech Tuesday. And today I am with Alexander Britkin from NFWare. NFWare is a partner of ours, so we were going to talk a little bit about carrier grade NAT, but specifically NFV and the benefits of that. So, Alexander, first, why don't you let everybody know about yourself and NFWare, and then we'll switch into what you're going to present to us today.
Hello, everyone, and hello, Rick. Thank you for having me here. My name is Alexander Bretkin. I'm the co-founder and the CEO of NFWare, and our company is pioneering network functions virtualization, as you can tell from our company name, from 2015. So 10 years, actually.
That's awesome. Okay.
What we do, is we are the software developer of the networking software for telecom operators and data centers. Sorry.
Great. Okay. And I want to let everybody know, let me see. Yeah, unfortunately, I'm not seeing, I've been having a technical problem where I can't display the chat on our screen, so I can't show chats on our screen, but I can see them here. So for anybody that is watching, if you would like to participate in the conversation or have a question specifically about NFV or carrier grade NAT or something like that as we're going through this, then feel free to go ahead and type that in YouTube chat. I'll see that, and I'll stop Alexander at some point and ask him that question. So again, thanks to everybody for joining us. Alexander, I'm going to go ahead and switch. I got to bring your screen on here. Sorry, it looks like that's gone, so I'm going to go ahead and put that on here. All right, there we go. So I've got your screen up now, so you can go ahead and start. Tell us a little bit about NFV, and you're ready.
Yeah, sure. So NFV, the Network Functions Virtualization, is the pretty old concept today. It started in 2012 from the white paper made by big telecom operators with an idea: why don't we get rid of the expensive hardware and switch to software-based networks? So here you could see with my laser points the original picture from that white paper, and you could see from its look and feel how old is it. And we have a newer one in the following slides, but the general concept of why would we want to switch from proprietary hardware to software-based networks is that would be more affordable because the software based on a standard x86 server architecture is just cheaper usually than a proprietary hardware. It will be more scalable because software scales better than proprietary boxes. Software is easier to deploy, it's quicker to deploy, it is as reliable as hardware. That may be surprising for some of the folks, but actually our company has proven that we have been proving that for already 10 years. We can show some numbers in the following slides. And that software is actually fast as today, that would be 440 gigabits per second. So that's pretty impressive. So that's why it's a very interesting concept to consider, and the time has shown that that's also a reliable one.
And you mentioned flexibility. So I guess, obviously, if you've got some proprietary hardware, a vendor is only going to sell that probably in so many sizes, right? So you got maybe small, medium, and large, and maybe not even small sometimes. So this allows you, I guess, to buy the hardware that you need at the time, enough to scale to a point, but you're not locked in as much, and you've got more choices, right?
Correct. So we have another picture in our presentation. Why would NFV be a better option? So on the left side, you could see that a hardware boxes, they are fixed in their nature. So they have as many ports, as many cards, as they can fit, and you can do nothing about it. Well, you can buy another box. On the contrary, the virtualized solution, the cloudified solution. So if you take this x86 server, you could install, for example, two virtualized CGNets on top of it. Or you may want tomorrow to deploy CGNet and load balancer. Or the day after tomorrow, you could deploy another solution like a firewall on top of that, and that gives you so much flexibility that you cannot ever get from the hardware-based platforms.
Mm-hmm. And I guess as far as redundancy, when you say you're installing two CG NATs, is that redundant, or you probably need two, just like you would need two proprietary hardware devices, you would need two servers just to make sure it's redundant?
Yeah, so there are two types of redundancy: the software redundancy and hardware redundancy. In this case, we look here at software redundancy.
Okay.
And if you would need a hardware redundancy, you would need another server and install CGNet on top of that. So this is just an example that on the same server, you could use two different functions, or three, or one, or four. It doesn't matter. That's the flexibility, where the flexibility comes in.
Got it. Thanks.
So, okay. So what about comparison? Look, there are several deployment options. We will go from left to right. So here we have the old, known and famous hardware appliance. You just buy it, you just install it, and you just manage it, and that's it. Solid box. Then, if you want to have a little bit more flexibility with the software, you could use the x86 hardware, install a host operating system, usually Linux-based systems, and on top of that, you can run the application. That's the a little bit more software-like solution. Then another, like if we go further with this concept, we could, instead of just one application, we could use hypervisor, for example, KVM, and on top of that, install the virtual machine. That is kind of the same as the bare metal, but it gives a little bit more flexibility to reinstall and to utilize the virtual machine. Where the beauty of virtualization and the sister of virtualization, containerization, comes in, is where you can install several applications, virtual machines, or containers on the same hypervisor. As in my previous example with the NAT, you can install firewall, load balancer, database, or whatever else you want to install. So we here, to talk about, I will show it with my pen, about these two options, and show how an example, how the ISP, the broadband operator, can utilize the virtualization to run a virtual function, for example, CGNet, for its networks.
Gotcha.
So, no questions so far?
No, you can continue.
Okay. Okay, let's go. Recognize this picture. It's we remade it. That old one, which was from 2012. We made it a little bit more, modern. So we pick one function as an example from here. Yeah, this body, carrying great net, and we will show in our in our webinar today what we can do about it. So let's go to practice. So in the first place, what is carrier grade net? Two words. That's the thing which almost every broadband, wireless, whatever telecom operator needs. Because there is a shortage of IPv4 addresses, and in order to cope with that problem, operator, they need either buy more IP addresses, IPv4 addresses, or to utilize, to install some function like a carrier grade net in their network. They can do that in a hardware way, or in a better way, software way. So this function, essentially, it works in the following way. So it pulls the public IP addresses away from the customer side, and uh, it allows in its private network, in its internal network, for several subscribers to use to share one IPv4 address when communicated to the outside world. That works almost in the same way as you have a wireless router in your house, where your all of your devices like smartphones, iPads, TV, they operate in internal network where they have their own private IP address. But for the external world, they communicate with external world utilizing just one public IPv4 address. So it's the same concept, but on a region or country level. So there are two main flavors of NAT. NAT 44, where you translate IPv4 address. So like here is the household device. It goes to the CPE, for example, your wireless router. And this private IPv4 address, it translates to public IPv4 address here. And another one is 64, where your IPv6 device may communicate with the external world, uh, which is some usually not usually quite often is still IPv4. It will communicate using NAT64 device. So that's the two main flavors to consider. Now,
So, so
yeah,
yeah, question. So, and just this is, we've got a lot of internet service providers that are watching or going to be watching this over time. So some of them may be new to the business, or maybe thinking about getting into the business. We've got a lot of broadband funding that's going to be being released here soon. So people might be thinking, well, IPv4, that's old. I'm going to be getting IPv6 addresses. So they may not realize that the two are not compatible. So IPv4 it was very limited. It didn't seem limited at the time, but there's just over time we've got so many devices on the internet, so many users on the internet that, as you mentioned, we have a shortage of IPv4 addresses now. So IPv6 was developed, but it's not backward compatible, right? So I think the issue we have, just for those to clarify that, for those that are not sure why this is an issue, is because there's still a lot of IPv4 content out on the internet. So websites that subscribers may want to go to, for them to reach that, they need an IPv4 address, and that's where you either have to supply a public IPv4 address for every subscriber, because you don't know who wants to go to get that content, or you need carrier grade NAT to be able to oversubscribe that among many subscribers. Correct?
yeah, absolutely correct.
Yeah. Okay.
So the IPv6 solution was invented a while ago. However, IPv4 is with us for a long, long time. As you, Rick, said, there are so many IPv4 servers, services, applications which were designed without having IPv6 thing or the philosophy in mind, and they will operate for quite a long, long time. And that's why the CGNet is a function, is a network function, which will be required also for a long, long time, unless an operator wants to buy a lot of IPv4 addresses for subscribers.
Yeah, and that's painful. I mean, IPv4 addresses used to be free. When we started out, seemed to be plenty of them, so they were just handed out like candy. And these days, they're not free. You tend to have to pay quite a bit. I've seen, prices anywhere from $40 to $60 per address when somebody's buying an address. So that can add up quickly. So carrier grade NAT can definitely help there.
So it's like how it's called commodities market. So you can buy them, you can rent them, you can buy one, you can buy a block, you can buy a small block, you can buy a huge block, um, and yeah, the price is not that cheap.
Yeah.
So when a big enough operator usually decides which way they would like to go in order to increase their subscribers base. And if they want to increase the subscribers base, if they invest in marketing and in sales, so their subscriber base is growing. And they have two options. They either buy, no, three. They buy a IPv4 address, they rent a IPv4 address, or they install CGNet. So they make the TCO analysis: what would cost more, what would cost less, what is more economically beneficial in long term, and quite often it appears that installing the software like this is the best option from economical perspective.
Mm-hmm. Yep.
Um, so based on this function example, how we can compare different ways um, how we use this function in the network. Um, and the first one is hardware. Well, the performance. Let me check my pen. The performance is great. Yeah. So that's hardware after all. Then the scalability. This thing is poor. You cannot scale it actually. So if you want to, well, you cannot scale it down because
Mm-hmm.
it's solid. You
Yep.
can scale it up, but you need to go to a shop and and buy it. It's a little bit harder to buy a dedicated hardware appliance in a shop than just a simple x86 server. It's a little bit harder. um, that's why scalability is not that good. Is it to deploy? Yeah, kind of. You just install it, connect it, and it just works. You don't need to work with a Linux or virtualization, so that's a good thing.
Mm-hmm.
Hardware utilization. That's not that good because I mean you have a box and you utilize it. I mean, want it or not, but you utilize the whole box. You cannot pay for 10% of the box. You pay it in full. So
Mm-hmm.
that's not good. And because of that, the cost efficiency is also not that good. So you need to invest in the box today in order to be able to serve many customers in the future, but you pay today. So that's not super good. So let's see what if we install the function on a dedicated server. And this is the only function on that server. Um, that performance is also good. So there is a misconception that software is slow. Software is not slow anymore, guys. So the networking software, such as CGNet or routing or firewalls, they're actually quite fast. They can show quite good performance. As I mentioned, hundreds of gigabits per second on a single virtual machine. That's quite a number. So I think the performance issue is solved. Scalability. It's, it's still not super good, but because that's a single virtual machine on a dedicated server, so they kind of combined. But it's still a little bit better than a hardware appliance, than a fixed appliance, because it gives you a possibility to scale this single virtual machine inside the server, like down or up. At least you have an option to scale it down. So that's like, I don't know, a small check. Easy to deploy. Yeah, that's a little bit harder to deploy than a single hardware appliance because you need to get the server and you need to get a software and then you need to bundle them. That's makes it not as easy to deploy than just you install a fixed box, but still quite good. Hardware utilization. That one is better because um, you can utilize as much hardware inside the server as you want. For example, not two CPU but one CPU, not 12 CPU cores but four CPU cores, not I don't know, huge amount of memory but a small amount of memory. So that's a good thing, and because of that, it's cost efficient. Definitely, definitely, it costs less than dedicated hardware appliance, just only because from the hardware perspective.
Hmm.
Um, let's go to the must, the right must option. That is when you utilize the same server or multiple VMs. So on the same server, you can run a virtual machine for CGNet and, for example, load balancing. So the performance is slightly lower because you need to share the same hardware with another virtual machine, but
Hmm.
still it's quite good. The scalability is much better. Just think about it. You use the same hardware for two different functions. They are two separate functions. You can upgrade, scale down, scale up them, independently. That's a great thing. Easiness of deploy goes down. Yeah, now you need to manage not only the server, you need to manage the virtualization layer and two more virtual machines. That's definitely a little bit more difficult than managing, a single virtual machine. So we give here a small minus. Hardware utilization is perfect. You utilize the whole server, not just for one virtual machine, but for many virtual machines. So that's a very wise choice. And because of that, it's very cost efficient. So you do not need another hardware for load balancing and NAT. You can use the same hardware platform. That's great. So check,
Hmm.
check, check.
So
So
I assume if you're going to be using, let's say, two functions like load balancing and CGNAT, you know that going up front, so you're just going to size your hardware a little bit different. Would that be right?
yeah, yeah, yeah,
Mm. Yeah.
definitely. So because they are different functions, they require different capacity
Resources.
of
Yeah.
server resources. Yeah, so you need to think about it like how many cores or memory you need to allocate for different functions. That's yeah, that's a job. And look at this. That's a fair example. I mean, if I were if it were a sales pitch, so the right column would be all green, all check
Yeah.
marks.
Yeah.
So that's a very fair assessment of
Hmm.
what is it for you. What is it for a network operator to run a hardware appliance versus single dedicated virtual machine or multiple virtual machine on
Right.
the same on the same hardware, and so it comes with different operational layers. So in talks and in doing business with our customers, the biggest and the most important obstacle and I would say issue or the problem they need to solve before they go fully virtual is who is going to manage that. Because before you buy a fixed dedicated hardware and there is one guy, the network engineer, who will manage that. Now I don't know if you can tell from this picture, but they are. It should be clear that this lady is the hardware engineer, so she's working with some motherboard or networking card, and so they take care of hardware like CPU, memory cards, networking cards, etc. So that's in big companies that's a dedicated function. Then host OS. So for example, Linux. Um, Also another layer to operate. And so this lady is doing the host OS administration. There is also a hypervisor. Usually they are quite interconnected. with the operating system. For example, in case of a KVM, that's a Linux thing. So usually those are combined in one role, but that's another layer where you need to understand that each new layer it kind of adds flexibility, but at the cost of complexity a little bit. And the final layer is the application layer here, the rightmost administrator. Yeah, so this person it can troubleshoot and manage the application itself.
Mm-hmm.
So when we work, when NFWare works with the with the partners like Zcorum, we make it like from one-stop shop. Yeah,
Mm-hmm.
so the whole thing is managed by one entity. But if but a bigger, I see in the market that a bigger networking companies, the bigger wireless operators, they have dedicated team for each of the layers, which makes sense. And if before they had the CTO vertical and the CIO vertical, now it's quite often that they are merged into CTIO.
Mm.
Yeah, that's that's life today. Okay, let's go.
Yeah, good. Yep.
So if um, if an operator wants to start with a going virtual, and if they think there is something in there and they want to explore whether it's really that good and beneficial for them, running a needed function like CGNet as a single virtual machine on a hypervisor is a good start. Well, first of all, it's a function which they need anyway, hardware or software. But also from operational perspective, it's quite clever. It's quite smart to to start not going fully virtual, like to virtualize all of the functions they have in the network. That's quite a big project, especially for smaller networking companies. But it's a good thing. I mean, this example is from our experience also, and from experience of our customers. It's a good way to get expertise to how to run a network utilizing the virtualization technologies, which is at the end, I think we will come there, and all of the networks will be at least this level of the network will be virtualized. So this is a quite a good start. The function is not that mm, difficult to operate after all. So let's look. I promised to show you numbers. Um, there is a big question about the performance. And the biggest, as I said, the biggest misconception about the software and the virtualization is, oh, software is a little bit slow. Oh, software is like it's not as reliable as a hardware, or you know, we trust hardware because it's and not software because we experimented with Linux and something, and it was not as reliable as we wanted it to be. Well, that problem, at least for the networking functions we talk about, is solved. And today, depending on the server you have and the number of CPU and the number of cores you have on that server, you can run up to 440 gigabits per second on a single server. That's quite a
Mm-hmm.
big number. And, like 5 years ago, I think this number was maybe 100 gigabits per second maximum. Yeah, but today the server innovations is going on. The CPU, the semiconductor innovations are going on. Then we also, the software developers like us, they optimize and they improve the software, you know, continuously. So I believe that we can talk in a year about 800 gigabits per second from a single server. So the performance is not an issue anymore. At least for this type of function, for this type of network, that's a solved problem. Okay,
So if
and yeah.
I was going to ask if somebody's considering this and they're looking at how much throughput they need, they're looking at, I guess, the throughput of their network. So give us kind of a quick overview of when somebody's first going to be doing this, how they would decide what size hardware, what specifications they would need.
That's very very simple. So they they understand which part of the network they want to try, with a virtual function. That could be the whole network. They they understand what is the throughput in that network, in that part of the network, considering the peak hours, and the forecast, what it could be, in, in some time. So different network engineers plan differently. And then they just look at a table like this, and they see, okay, so I have 100 gigabits per second. That would require me one Intel Xeon Gold 6230 with the one networking card, and that is about 26 CPU cores. And that's not something fixed, in a sense that, this could be not just one CPU, it could be two CPUs each with 13 CPU cores. That would give you 26 cores in total. That's fine. This could be also not just one 100 gigabit Ethernet ConnectX networking card. That could be 10 networking cards, each for 10 gigabits per second. That's also fine. That will work. So, but the function, the virtual machine will be the same. So that's where the flexibility comes in.
Right. So like you mentioned, they want to look at what their throughput is now, and then maybe depending on how they expect to grow, for example, a new internet service provider is going to start smaller, but they could grow quickly. Or if they're going to be expanding their territory, maybe they're going to be getting funding to expand. They're going to want to think about the future. Now, in a situation like this, where you're saying that you've got the one that you've got pointed out there, the 100 gig. So if they bought a machine, a piece of hardware that matched these specifications, if they needed to upgrade that in the future, are you saying that they could get just another NIC card, or add something to that and not have to completely replace the whole machine?
Yeah, that's right.
Okay.
So the real life example would be, we so a customer comes to us and say, okay, guys, so we were 100 gigabits per second. Now we are growing. We expect to be 200 gigabits per second of throughput. So what are our next steps? So what we say, okay, now if there is no more capacity in this server, you would need to buy a new server, new like a bigger server, and once you have it, we help you to migrate the existing virtual machine from the old server to a new server, and you just need to pay the additional 100 gigabits throughput license on top of that. So you kind of scale it, and you can use it like instantly. Sometimes, if the existing server is good enough, they just insert more networking cards and more memory, and we scale up this networking function inside the server, so we don't even bother with the new hardware.
Gotcha. Okay. Yeah, that's definitely more flexible than something proprietary. Yeah.
So when they when they buy a virtual solution, meaning they buy software, the virtual networking software, and a server, they actually make a good investment decision, because if they would need to change the hardware, the underlying hardware, they do not need to repay the software license. And the cost of the the x86 platform that's incomparable with the dedicated hardware appliances.
Yeah.
Just another order of magnitude.
Mm-hmm. Excellent.
And the cost thing. The cost thing is very important for rural broadband.
Mm-hmm.
As we know, rural America is a little bit underserved with a high-speed internet connection. What can we do about it? We can explore the option to build the affordable network utilizing the virtualization technologies. Why it is affordable? So we explained a little bit earlier. At the same time, it's scalable. So the rural broadband, it scales fast. Today you have one town, tomorrow they have 3 towns. So that's the nature of the business. So the scalability is the thing. And you probably do not want to invest into too many towns in day one if you expect them to be connected with a fiber like in a year from now. That would not be smart. That's easy to deploy. Again, I try to explain that why. I mean, it's not the easiest option to deploy, but still, if they have the expertise in servers and a virtualization layer, or they work with a partner like Zcorm, that's solved. It's quicker to deploy because it's software. When you have a hardware platform, the only thing you need to deploy the networking solution is to get the license key and download the virtual machine. That's quick. It is reliable. We have proved that during our 10 years journey. So today our company serves hundreds of millions of subscribers across the world. And we work in many tier one companies with, not just hundreds of gigabits, with tens of terabits throughput. So that's a very reliable thing. And it's also fast in terms of throughput. So you can have from a single server hundreds of gigabits per second of throughput. That's a good thing because if you build a fiber networks, and I hope many companies do fiber networks today, not coaxial or DSL. The throughput is a key thing. We are not too far from a moment where many households will have 10 gigabit per second connection. That's quite not too distant reality. So, and on this positive note about how we can help the underserved communities with the high-speed internet, yeah, would be great to have some questions.
Mm-hmm. Yeah, and again, this is very important because a lot of these folks that are going to be getting funding are going to be obviously expanding quickly. So it could be an existing service provider that's going to be edging out their territory, and they're suddenly going to have a lot more prospective subscribers there. Or it could be somebody that's brand new getting in the business. And they may not realize the fact that, again, even though they might completely deploy their network infrastructure on IPv6, they still need to have an IPv4 address, public address, that they can give every subscriber in order to provide the service. So I don't know if you are going to mention this, but we talked about the fact that you can have multiple people sharing one address. And I believe that that could be 128 or more subscribers sharing one address. Is that correct?
That is correct. Yeah. So our standard advice when we are asked about so how many people should I hide behind one IP address is, okay, let's start with a 120, 128 and see. But it would depend on the type of the network. For example, if there are too many gamers, you may need to reconsider this number.
Mm-hmm. Gotcha. Okay, so it depends a little bit on what people are doing.
Yeah.
Yeah. So I think that's going to be the state of as more internet service providers move over to IPv6, they still have this what seems to be an unending dilemma where they've got to have an IPv4 address still so that people can get to that content. So this is the same for rural America, but I think in the rural example, it's even more clear because they're going to be growing the fastest. So for an internet service provider their subscriber base has been fairly static, maybe they're not feeling the pain, but once they start to expand, it's going to be an additional cost for every single subscriber they put in. So carrier grade NAT can really make a difference there.
Yeah, Rick, especially in the case of rural broadband in some rural areas where people just use computers, not just internet, but computers in a little bit different way than the big cities. I would say the network engineers, they still may meet people with Windows 95. So yeah, what IPv6 we're talking about. So yeah, we need to be ready for backward compatibility.
Yeah.
Really.
Okay. All right. I don't know if I didn't look at your deck to the end here, so I don't know. Do you have more slides?
That's yeah. As I said, yeah, it would be great to have some questions, and yeah, that was the last slide.
Gotcha. Yeah, and I don't see any questions on YouTube, so we either explained everything perfectly well, or we were like so technical they don't know what to ask. Hopefully everything was explained. But just for everybody out there that's watching, again, we're a partner of NFware, and we kind of bundle services together with what they've provided, and we can also help. Talking about the rural broadband, again, you might have a service provider that's going to be starting out with just a very small number of subscribers, and as you had mentioned when you were talking about the proprietary hardware issue, they would have to buy a piece of hardware that would support way more than just a few subscribers. So the benefit of going with someone like NFware and through Zcorum is you can start really small, with your licensing, and then you'd buy enough hardware to get you up to quite a number of subscribers. But again, that's going to be much less expensive than buying proprietary hardware. And then your license can increase as you increase the number of subscribers, the throughput really. Then you can increase the license as you go. So you can start out small. Your costs are going to be starting out small, which helps, obviously as your revenue is smaller at that point. And the other thing that we can help with is if you are going to be doing multiple locations, we have a flexible pricing option, right? Can you explain that a little bit, where they're going to maybe multiple CGNAT device servers, but they can kind of put those together in a flexible license?
Yeah, that's a great thing. That's a great business outcome of dealing with the virtualized solutions. Mm-hmm. If you, in certain cases, if you buy a license for 100 gigabits per second, for example, you can divide it into several sites. For example, today I need 50 here and 50 here, but tomorrow I may need, not 2 sites, but 3 sites, and each of them is 30. So that's this kind of flexibility is another nice bonus. We didn't talk about it, by the way. So yeah, thanks for for mentioning.
Yeah, because again, I can envision again, some service providers that are expanding into new territories, and as they do that, they may have, like you said, they don't know what the subscriber base count is going to be in each location, so they can get the flexible licensing, and as one may grow faster than the other, and then eventually they can upgrade the total amount that they have. So it's a great opportunity there for them. So again, if you are in the business of internet service provider business, and you are looking for a way you may already be paying for IPv4 addresses, and maybe it's something you're leasing or you're having to constantly buy more, go ahead and check us out. So go to zcorum.com. I should have our phone number on here. I don't, but you guys can find us at zcorum.com. You can send an email to info@zcorum.com, or you'll find our phone number on our website. So give us a call. We work very closely with NFware, and we can help make a lot of this much more simple for you. NFware provides a tremendous amount of support for their customers and for us. So check us out, and don't keep paying for IPv4 addresses. It's not a smart strategy, especially if you're planning on growing your business, and hopefully you are. Hopefully, if you're an internet service provider, you have plans to add more subscribers, and that would be especially the case, obviously, if you're going to be expanding your territory. But hopefully, you even want to add subscribers in where you currently are. So, buying an IPv4 address is not smart. I think a lot of ISPs started doing it because they thought, well, eventually I won't have to do this anymore. But I still don't see the light at the end of the tunnel there. It seems like they're going to have to do that forever, almost. I'm sure that's not the case, but anyway. So, Alexander, I don't see any questions from our viewers. And let me mention also, I know a lot of times we'll get viewers that, we'll get thousands of viewers that'll come on and watch this later. So if you are watching this later, and it's like, oh, I didn't get a chance to ask a question because I didn't see it live, you can very easily just type a comment in YouTube. And when you do that, then I will see that. And if I can't answer it, I'll get with Alexander or one of his folks, and we'll get an answer for you, and I'll just post it right back there on YouTube. So if you have questions about carrier grade NAT or NFV, something that I definitely could probably not answer. If it's about something really technical, then I'll make sure I get with Alexander, and we'll get your question answered there, right on YouTube. Thanks, Alexander. I appreciate your time.
Thank you, Rick, for having me, and it's always a pleasure to be on your Tech Tuesdays.
Yeah, it's always a pleasure to talk to you. We talk regularly, so it's good seeing you here. Thank you, everybody who's been watching. And again, reach out to us if you have any questions. If you need a solution, carrier grade NAT solution, this is the one to get. So reach out to us, and we will help you with that. Take care, and I will see you next time. Bye-bye.